Hello, everyone. We are the Tensor team. Our members consist of myself, Adam, Marcel, Blake, Derek, and Nathan. Over the past semester, we've been working on RMAX. RMAX is a prototypical C++14 interface over MPI3 RMA, which focuses on providing a thin layer above MPI RMA, and at the same time aims to improve the programmability of MPI RMA. Over this past sprint, we have been mainly addressing issues arisen from Sprint 2, those being the debug branch and our features prototype.
Hi, my name is Marcel, and I'm here to talk about RMAX's distributed computation model. Specifically, RMAX, in addition to allowing communication across processes, also allows computation across processes. And so we just have made some improvements to some issues that we had in our previous model, but we had to start from the ground up to do that. So here you can see we initialized two windows, which is our distributed data model, with some values, and then just do some simple operations on them with addition and division. And I can go ahead and run that here. And you can see that they are using different data. So this is using data from process 0. This is using data from process 1, which is changed down here. But all of this is just in service of allowing the user to more easily and more expressively compute with the data that's kind of distributed across their processes here. One of our biggest changes that we made is with this flush all syntax. And so this represents synchronization. So making sure that all of the processes communication is done, allowing you to actually evaluate. But users may want to delay that synchronization because it's kind of expensive. But before, we used to have to do it all at once. And so by breaking it up like this and allowing each window to flush, we give the user a little bit more control. Behind the scenes, this is also using some new C++ features, C++ features, I think they're called. And that allows for asynchronous code to run, which is kind of what we're looking to do here. And it just allows for our library to be a bit more future-proofed using the newest features of C++.
Hi, I'm Blake and I'll be discussing our activities and progress thus far. Concurrently, we've explored several designs for our expression syntax. One attempt focused on securing an MVP most efficiently. This attempt was largely successful. Another, simultaneously taken approach, looked for optimizations in our storage structures. Unfortunately, this was less successful, but we will continue fleshing this out into the next semester. We also integrated more modern C++ features within RMAX, introducing C++ concepts, and we researched implementations with C++ ranges. Speaking of our expression syntax, handles, before it had static methods, which meant all synchronization must happen at once. It had untyped allocations and a singleton design pattern that was inflexible and hard to work with. Afterwards, the new implementation of handles has instance methods which decentralize synchronization. It replaced our singleton with instance features using a standard vector of shared futures. This has the added benefit of no untyped allocations within our code. Overall, this adds immense value to handles, as anyone who works on RMAX now has a more usable foundation to build on top of. It also has much more readable code, which will provide better error messages for both users and developers. The knowledge and skills we learned and applied to complete these changes were a new C++ template structure, and as the prototype required thorough design involving intimate knowledge, we had to apply both MPI. The knowledge and skills we learned and applied to complete these changes were new C++ template structures, and as the prototype required thorough design, it involved intimate knowledge of both MPI and RMAX. Challenges in implementing the new handle system included having to completely redesign it, as the old system was almost entirely unused in this effort. And as it was one of RMAX's core features, a lot of thought needed to be put into the minute detail of the redesign. I will now pass it off to Derek for C++20 concepts.
This sprint, we began to research and implement C++20 concepts for integration into RMAX. Concepts will improve the usability of the interface by giving users concise and informative error messages when debugging the code. This should drastically cut down on the time that the user spends debugging. As we researched concepts, we learned how to design them in such a manner that they can be used and reused in many areas of the code. Some challenges that we faced are concepts are new to everyone in the group, and we were unfamiliar with them prior to this sprint. Concepts are also extremely difficult to design generically for reuse in many areas as opposed to being specific to one instance. Ultimately, we had to overcome these challenges with additional research and by writing dummy concepts to practice designing them. These concepts were not necessarily something that we would want to implement to RMAX, but gave us experience designing and implementing concepts. On this slide, you can see an example concept called contig. This concept checks that the container, C, has the data member and that the elements are stored contiguously. Below the contig concept is the error message without the concept implemented. As you can see, this produces a large error message that is difficult to understand and does not tell the user exactly why the error is occurring. All the user knows is that there are some mismatch types. In the second error message with the concept implemented, you can see that the error message is much clearer and tells the user that the problem with their code is that the container does not contain the member data. The second message is much shorter and provides the user with a better understanding of why the error is occurring. On this slide, you can see our untested concept called copy constructible. This concept is supposed to verify that the variable ILO has a copy constructor. In the next sprint, we hope to flesh out this concept and add additional ones into the RMAX codebase to improve the usability of the interface.
Retrospective. What went well? Both groups continued with their current roles, and we made progress on our goals that we had set before. Our communication has been great for this sprint as well. Our meetings had full attendance this sprint, and Microsoft Teams has worked great for our messages and meetings. What we'd like to improve. We still want to establish better meeting times. This means coming together and deciding what days and times we want to meet at in the future. Currently, our meetings are still planned on a whim. This was partially influenced by finals week, which required us to weave our meeting times around studying and preparation for finals. Over the summer and the next semester, we'll set regular meeting times that we can all schedule around. In addition, we plan to actively resolve the current issues and push more commits. At the moment, we tend to develop a feature locally and then push once it's in working condition, but we plan to commit unfinished code as well to show our progress. We also plan to track issues in our sponsor's repository so that our progress is visible to him as well. Changes we plan to implement in the next sprint period. We've been considering switching to Discord as our main form of communication for a while now, which would replace Teams. We started with and are currently using Teams because it's what was given to us at the beginning of the course. We're more comfortable with Discord because we all use it in our everyday lives. This switch would take place over the summer likely. We also plan to slow down our meetings with our sponsor because most of us will be busy with other responsibilities. Instead of weekly, we plan to meet with him once every 2 weeks or so.